Hey friends, it's Unit 9, Notes 5 that we're going to be tackling today. So let's go ahead. It's on dividing rational expressions, and it's super similar to multiplying, because what you do is when you're dividing fractions, you just change the division to multiplication and you flip the fraction. And now it's a multiplication problem. Same thing with rational expressions. You're going to multiply by the reciprocal. So if you're still writing, pause the video here. If you're not, let's move on. All right, so find the quotient and state the excluded values. So we're going to keep our first one the same, and we are going to change it to multiplication, and we're going to flip our second fraction. So we're going to have the reciprocal. All right, so now is when we want to look at and say, ooh, I need to do excluded values. I get x cannot equal 0. So you have a couple ways here you can do it. We've talked about these in classes. You can multiply straight across and then simplify, or you can simplify first and then multiply anything you have left. So majority said they wanted to multiply first. So we get 105x squared over 70x cubed. So you want to go ahead and take your 105 over 70 and reduce it. And you remember your calculator can do that for you. And that reduces down to a 3 over 2. And then we have one more x in my denominator. So there's my simplified expression. There's my excluded values. So let's go ahead and look here at the next one. My first fraction stays the same. And my second fraction, or it changes to multiplication, and I flip my second fraction. And now, if I look at this, I want to say my excluded values. All right, so I was just thinking about those excluded values. Didn't really make a difference in number 1, but it does here in number 2. We probably actually want to find our excluded values here when we have a division, and then we're going to have to double check to make sure we got it all in this flipped fraction. So really, we want to say d cannot equal 0 and e cannot equal 0, and that comes from this original. But then here we need to also include c cannot equal 0. Okay, so we're finding excluded values all over the place. All right, so let's go ahead and multiply your enumerators, and you get 27 times 9 turns into 243. All right, we have a c cubed, d to the 5th, and an e. And then in the denominator, we get 22 c cubed and a single d. So my c cubes are going to cancel. Okay, I just see that right off the bat, so I'm going to write that down. 243 over 22 actually does not simplify. So 243 over 22, I get a d to the 4th in the numerator and an e in the numerator, because this d on the bottom here is going to simplify out. All right, simplified answer and excluded values. All right, so go ahead and look here at number 3. We are going to look and do our excluded values here. So I'm going to take my first one and I'm going to simplify it. And so based off that, I want to say b cannot equal a -1. And if I look here in my denominator of that, I can also say b can't equal -1. So I'm going to change it to multiplication, and I'm going to go ahead and flip that second fraction, and I'm factoring it at the same time. Now, at this point, I need to say b cannot equal a -4. I'm looking for things to cancel. I could cancel all of those. So in the numerator, I only have a 1 left if there's nothing up there, and then 2 times 3. So actually, it simplifies to 1/6, and my excluded values here are a -1 and a -4. All right, so I want you to pause the video and give problem 4 a try. Okay, so just checking in. I did simplify the first fraction, and I got a b cannot equal -5. And then based off my original fraction for division, also would say not a -5. All right, pause it, make sure you keep going. Okay, so here I flipped my second fraction and factored it. So now, based off this, I would say b cannot equal -9. All right, so did you catch, we have a 6 in the numerator, and then we have a 3 and a 2 in the denominator, and 3 times 2 is 6. So that 6 in the numerator and the 3 and 2 in denominator are going to cancel together. So we're left with b minus 2 over b plus 9, and my excluded values are here in my red. All right, let's go to the back side of those notes. Hopefully you're feeling pretty good about these and looking at it. All right, so if we look here, I'm going to just start off right off the bat. I see that I should say x cannot equal -1 based off this. So I'm going to go ahead and factor what multiplies to 2 and adds to 3. Well, the only things that multiply to 2 are 2 and 1. So I get an x plus 2 and an x plus 1 in my numerator over 4. Change it to multiplication, and I'm going to flip my second fraction. And now this denominator is going to give me an x cannot equal a -2. All right, so I'm going to go ahead and cancel out those. So multiple ways that you can write what's left here. You can say x plus 1 times x plus 1 over 4. Totally okay to have that for an answer. You could put x plus 1 squared over 4. Okay for that. Or you can FOIL/box method and get x squared plus 2x plus 1 all over 4. Any of those red solutions are a-okay with me. All right, so if we look here at problem 6, I see that x cannot equal a 0. All right, in my numerator here, I have a difference of perfect squares, so x minus 2, x plus 2, all over 5x. Change it to multiplication, and I'm going to flip that second fraction. And now based off this, I would say x cannot equal a positive 2. All right, so I can cancel out my negative x minus 2's, and I can cancel out x. Now notice, this is not going to change to 4x. I'm canceling out the x part of that. So I still have that 5. So I get x plus 2 over 5 for my simplified answer, and my excluded values lie there. All right, you feeling okay? If you don't, pause, rewind, rewatch, email me, ask me questions. All right. Whew, we got a little bit more here, but nothing we can't handle. We're tough. All right, so my numerator, I'm going to factor out a 2. Now my denominator, I'm looking for what multiplies to 18 and adds to 11. So that is going to be a 2 and a 9. So x plus 2 and x plus 9. Based off that, I'm going to say x cannot equal -2, -9. Okay. So then on my side over here, I'm going to factor this to come up with my excluded values there, and then I'm going to flip it. So multiplies to 6 and adds to 5, that's a 3 and a 2. So this denominator is x plus 2, x plus 3. So again, -2 is on the no-go list, and then also I'm going to add a -3 here. Okay, so I change it back to multiplication, and I flip this bad boy, x plus 2, x plus 3, and we're going to do some canceling. Oh, no, we're not going to cancel quite yet. We're going to go ahead and add in one more excluded value. So we're going to slide those down because I get this x plus 1. So I can't have it be a -1. All right, so, oh man, we really can't do much of any canceling, can we? Oofda. All right, so I think I need to make a little more room here. Oh no, stay down there. There we go. All right, so we could have 2 times x plus 2 times x plus 3 all over x plus 9, x plus 1. Or I can multiply everything back together. And so now this 2 in the front here, this 2, if you're going to multiply it in, only goes to one set of the parentheses, not both of them. All right, so when you FOIL in box method, this becomes 2x squared plus 10x plus 12 all over x squared plus 10x plus 9. Now, man, I really hope you're listening and not just listening and doing this on mute. These 10x's cannot be canceled because they are being added to other terms. Do not do anything with them. Leave them as is, ladies and gentlemen. All right. Ooh, number 8. Number 8's got a lot of factoring in it, but not anything we can't handle. So I'm going to leave it to you to try and just factor, and then you'll come back and we'll check in with each other throughout that one. All right, so pause the video here and work on factoring. All right, there's a quick peek here at the first one. So my excluded values, I'm going to state, are going to say x cannot equal -2 or -3. Okay, factor this piece to come up with some more excluded values. Okay, so written in purple there is that red circled answer factored. So again, -3, but this time I'm going to add on a -4. Okay, so go back and change this to multiplication and flip that second fraction. Okay, so in flipping and factoring that second fraction, we now also add in a +1 here for our excluded values. So cancel out what you can from the numerator and the denominator, and it doesn't really matter what fraction it comes from when you cancel. Ooh, we cancel a lot of them. So we get an x plus 4 over an x plus 3. There's your simplified answer, and then our excluded values are over to the left. Okay, so let's go ahead and do a word problem. And this word problem really doesn't really have division in it, but we're going to kind of go through it. Okay, so in 2001, NASA launched the Mars Odyssey spacecraft. It took 200 days for the spacecraft to travel 466 billion miles. And this actually should say kilometers. It's not miles. It's like 295,000 miles or million miles, something, I don't know. All right, what was the average speed of the spacecraft in, let's just go with kilometers per mile. We'll just start with that. All right, so it went 466 million, not billion, sorry, my bad, in 200 days. So this is kilometers and days. Yeah. Okay, so we want to first move it into kilometers per hour. So we're going to leave kilometers, but we want to change days into hours. Okay, so we're going to put 1 day on top, and we're going to put 24 hours in the bottom. So our day cancels, and what we're left with is taking 466 million and dividing it by 200 times 24. Now, when you do this, if you put it all in your calculator, you need to put those two in parentheses. Okay, and then it says round to the nearest mile. Okay, so when we do this, we get 97,083.3. So that doesn't round. So this is in kilometers per hour. That's pretty good, guys. All right. Now, if you wanted to change that into miles per hour, we would have to do converting between kilometers and miles. And I think we're just going to skip that for today. All right. So number 10 talks about on July 7th, 2003, the rover Opportunity was launched. It landed on Mars on January 25th, 2004. Assuming that the Opportunity traveled the same distance as the Mars Odyssey spacecraft, how far did the Opportunity travel? Round to the nearest, and it says miles per hour. Again, we're just going to talk kilometers per hour. So this one doesn't tell you how many days it traveled. So you have to do that, okay? So it launched on July 7th. So how many days are there in July? Well, July has 31 days, but it didn't launch on July 1st, it launched on July 7th. So from 7 to 31 is actually only 24 days traveled. Okay, then it went for August, and August has 31, and it's in September, there were 30, October has 31, November has 31, and December has 31. January also has 31, but it didn't travel all those 31 because it landed on January 25th. So it only traveled 25. So go ahead and take 24, this 24 plus your 31, 30, 31, 31, 31, and 25 to find out how many days did it take for this Mars rover to travel the 466 million miles. Oops. Okay. And that was 203 days. And we have 1 day is 24 hours. Okay, so day again is going to cancel. And this one again says round it to the nearest kilometer per hour. So go ahead and do that in your calculator. So this rover traveled a little bit less per hour, went a little bit slower. It only went 95,649 kilometers per hour. All right, ladies and gentlemen, there you have it. We will see you later.